girls. Hey Kathy.
Hey Kathy.
Phantastic Physics!
Good morning everyone. Today we will be learning about kinematics.
Wait, what are kinematics?
Well, Kathy, kinematics are equations we use to solve for variables.
How many variables do we need to know so we can solve a kinematic equation?
Well, Gina, we only need 3 of these out of the 5 to solve for another variable.
Splendid!
Wait!
What if an object is falling off a cliff and moving horizontally?
Well, Kathy, that's when you split it up into its horizontal and vertical components because it is a vector.
What's a vector?
Well, Gina, a vector is something with both magnitude and direction. Something to remember is that the acceleration due to gravity on the surface of Earth is 9.8 meters per second squared. Yes, Marina.
What did one crazy physicist say to the other?
You're a kinemaniac!
Hey, girls.
Hey Kathy.
Fantastic Physics!
Good morning, everybody. Quiet, because now it's like quiet. Okay. Good morning, everyone. Today we'll be learning about Newton's laws. There are 3 different laws. The first one states that an object in motion stays in motion, and an object at rest will stay at rest unless an outside force is applied to it.
If an object is not moving, does it mean there's no forces acting upon it?
That's incorrect, Marina, because you see, me standing on the ground, if the ground wasn't here, I would just keep falling downwards. But there's a force from the ground on my feet acting upward, which is called the normal force. And my weight acting on the ground, which is my weight. Newton's second law is F equals ma. The sum of the forces equals mass times acceleration. If I apply a force to this book, Kathy, do I add up all the forces acting on the book to find the sum of the forces?
No, silly. Only the forces in the horizontal direction because the verticals, normal and weight, cancel each other out.
Those forces that you just said cancel each other out are equal and opposite forces, which is Newton's third law. So Marina, can you summarize Newton's laws for me, please?
No, I'm a physics student, not a law student.
No, Marina, Newton's laws are about physics.
Hey girls. Hey Kathy.
Hey,
Fantastic Physics!
Good morning, everyone. Today we'll be learning about energy.
Wow, you have so much energy today.
There are 2 main types of energy. Potential energy, which is like a rock on a cliff. It has the potential to fall off the cliff. And then there's kinetic energy, which is like a cart rolling on a track.
How do you find potential and kinetic energy?
So, the equation for potential energy is mass times gravity times height. And then the equation for kinetic energy is 1/2 mass times velocity squared. And you see how in kinetic energy, there is no height in that equation. So, when the cart has kinetic energy and no potential energy, that means there is no height and it's on the ground. Does that make any sense? Yes, Marina.
Why does a hamburger have less potential energy than steak?
Because it's in the ground state.
So are there other types of energy?
Yes, Gina, there is spring potential energy. Say, this is the spring. That's a mass hanging. The K is the stiffness of the spring, and the X is the distance the spring is stretched from equilibrium. Hey girls.
Hey, Kathy.
Phantastic Physics.
Bling, bling, bling. Wow, thanks for that demonstration of momentum, guys. The variable for momentum is P, and the equation is P equals mass times velocity. There are multiple types of collisions.
What are those?
Well, students, there are inelastic and elastic collisions. In a perfectly elastic collision, the kinetic energy will be conserved. And then in an inelastic collision, the kinetic energy will not be conserved.
Thanks for teaching us momentum, Teacher Jewel. You the real MVP.
Equals.
P.
Hey girls.
Hey, Kathy.
Phantastic Physics.
Good morning, everyone. Today we'll be learning about circular motion. The kinematics for circular motion are the same as the kinematics for linear motion.
Wow, even the variables?
No, silly, the variables are circularized.
Oh!
Wait, well, how?
Well, I'll show you.
The fish thing.
Something to remember is that when something's traveling in a circle, it is always accelerating because it is changing direction.
Well, how do you find the acceleration of something moving in a circle?
Well, Gina, that would be the centripetal acceleration. To find the centripetal force, you do the mass times velocity squared over the distance. You see, this is really F equals ma because this acceleration is substituted in here.
Wow, that really threw me for a loop. What?
What is the universal law of gravitation?
Well, Kathy, that would be G is a constant. M1 is the mass of the thing the object is revolving around. M2 is the mass of the object revolving around the other object. And that is the distance between them. Hey girls.
Hey, Kathy.
Phantastic Physics.
Good morning, everyone. Today we'll be learning about rotational motion. Kathy, can you tell me what torque is, please?
Sure, teacher. Torque is a perpendicular force applied at a distance from the fulcrum.
Correct, Kathy. The equation for torque is force perpendicular times radius.
Is there a way to find the sum of the torques without having to add them all together?
Yes, Marina. The sum of the torques also equals inertia times angular acceleration.
What's inertia?
Good question, Gina. Inertia is the tendency of an object to resist the change in motion. And the equation for inertia is equals mass times radius squared.
Wait a second. Is there rotational kinetic energy too?
Yes, Kathy, there is. Oops. Inertia times angular velocity squared, with the 1/2 in front. Yes, Gina, do you have a question?
Is there rotational momentum too?
Yes, Gina, that's called angular momentum. And that's angular momentum equals I omega, or L equals R times linear momentum. Lerp.
Wow, the rotation of the Earth really makes my day.
Burp.
I do.
Hey girls.
Hey, Kathy.
Phantastic Physics.
Waves and sound.
Did you say waves?
Yes, Kathy. Go sit down. Okay. This is a peak. This is a trough. And the distance between one peak and another peak is one wavelength. Lambda. See how this is lambda when this is the distance. But when it's time, then this becomes the period. Wave speed equals lambda wavelength times the frequency. And the frequency is 1 over the period.
How do you find the velocity of a wave on a string?
Well, Gina, that's a good question. The velocity of a string equals the square root of tension over mu. And this mu is different from the other ones. This one equals mass over length.
So you're saying that when you're hanging loose, there's less velocity on the string?
Yes, stupendous, Marina. Hey, girls.
Hey, Kathy.
Hey, Kathy.
Phantastic Physics.
Good morning, everyone. Today we'll be learning about electrostatics and circuits.
We're attracted to each other because we're of opposite charge.
Thank you, Gina and Marina, for that wonderful demonstration of the electrostatic force. The equation for the electrostatic force is and then, okay, this is a constant. This is charge 1, this is charge 2, and that's the distance between them.
Well, that's electrostatics, but what's circuits?
Well, Marina, we will get to that right now. This is current. Current equals number of electrons over time. And then there's resistance. Resistance equals rho times the length over the area.
What about voltage?
Well, Kathy, according to Ohm's law, voltage equals current times resistance.
Are there different types of circuits?
Yes, Marina, there are 2 types of circuits. Well, in our case there are. There are series and parallel. In series, the current stays the same and the voltage gets split up. In parallel, the current gets split up and the voltage drop stays the same. Well, we know that power equals work over time, but right now, in circuits, power equals current times voltage.
My friend Power is really stressed. His boss is making him work overtime.
Oh no.